Well, a very warm welcome, very hot welcome from Johannesburg today. And it's so wonderful that you've been able to join us for the first Bite-Sized Corrosion series of 2024. My name is Vanessa Sealy-Fisher, and it is my great pleasure to host today's session. Now, today we're starting a 6-session series looking at pipeline field joints, and we're focusing specifically on the coatings and linings. Now, I'm acutely aware that not every engineer is a pipeline engineer. And although pipelines are our focus over the next 6 weeks, we hope that you'll still find it informative and interesting, even if pipelines are not really your thing. I'm absolutely delighted to welcome Neil Webb, well known from Isiniti, back to the microphone today. Neil has been really active in the corrosion sector for 45 years or more. In fact, he's often referred to as South Africa's Mr. Corrosion. Neil, you've got a wealth of experience and expertise, and we're really honored that you're so willing to share that with us today. Now, let's focus in. In a pipeline construction project, we need to consider the corrosion protection of the field joints. We know that the pipes are manufactured and largely coated and lined in a pipe mill or a factory, but they don't come in one long string to site. They have to be joined together in the field, and those joints vary. I know of butt welds and spigot and socket welds, flanged couplings. Neil, when we look at all these options, is there a particular caution or something that we need to have with our consideration of their coating?
Yeah, Vanessa, I think as with many coating projects, one of the primary considerations is the quality of surface preparation. The challenge with field joints is that we're no longer in the factory. So we have this high-tech coating that has been applied under strictly controlled conditions in a pipe mill, and the ends of the pipe are left bare, and then you get the welding guys who bring the pipe and weld them together and do their x-rays and everything else that needs to be done to create a hydraulic unit that is now a pipeline with only one hole. That's the one in the middle. The coating now has got this weak spot, if I can call it that, at every 20 meters in modern pipeline production. The random pipe length is just short of 20 meters. And so every 20 meters, you now have to go in there and prepare that field joint and coat it. And that coating now has to stand up to the same conditions as the rest of the pipeline. And that really is a challenge.
So Neil, you speak about service preparation. 2 things I've noticed. The first is that there has been surface preparation in the factory. And so my first question is, does that count for nothing? And my second question is actually the complete opposite. I've seen a couple of situations where they've coated with something over that field joint. So something different. So they've got let's just be colored. They've got a black pipe coating, and then they've got a red end for the field joint. Do those preparations not make things easier once we get to site?
Mm-hmm. That different color on the end, we call it the cutback, is a big bone of contention. For me, the challenge with that particular situation is that when you're in the field, well, let me step back one. The pipe mills puts that typically red primer onto the end in order to prevent flash rusting or tarnishing of the end of the pipe that is exposed. The problem with that is that that particular coating may not be compatible with the field joint material, and it has to be removed. It may also not be compatible with your cathodic protection systems. So you're actually putting a weak link into the system at every joint. In fact, it is far easier when you're in the field to remove a little bit of flash rusting than to remove that primer that has been put onto the ends in order to make it look pretty.
Sure, so it's a situation of trying to help out is actually creating a worse problem.
Yes. And sure, if you're going to have pipes that are going to be stacked or stored in aggressive environments, say close to the coast or something like that, then yes, there is merit in putting a coating onto those bare ends. But in general, for most situations where the pipe gets to the site and is then prepared and coated relatively soon after having arrived on site, my personal recommendation always is that you don't coat those ends. But that was the one question. What was the other one?
Does the preparation so the surface preparation in the factory, the pipe has been blasted to this shiny, beautiful surface. Does that count for nothing when we get to site?
No, it doesn't count for nothing. The blast cleaning in the factory removes the mill scale, which is the primary enemy number one in terms of any coating system, is that residual mill scale. So mill scale is that hard oxide layer that is on the outside of any hot rolled steel component. And pipes are fabricated from steel coil. That steel coil has got mill scale on the outside of it, and it's going to be there. So that is removed by the blasting in the factory. But then when you get to site, you may have some light flash rusting, as I mentioned, and there are many coatings which can be applied on site which only require that flash rusting and the tarnish from welding to be removed. And that can be removed typically by wire brushing, for example. So it's not necessary to blast clean on site unless you have some of the high performance coatings that are applied, such as liquid coatings, for example, which we're going to talk about later in the series. And there you have to re-blast clean. But having blasted in the factory already, it's quick and easy to do that blasting in the field compared to having to remove mill scale.
Great. Okay. So having now got the blasting out of the way, we now have a clean surface, but the factory conditions were pristine and site isn't quite as perfect as we necessarily would like.
Yes, one of the biggest challenges that we have, of course, is temperature. The pipe is sitting out there in the field. The pipe surface temperature may be 50, 60 degrees. And that can be a challenge for some of the coatings. Again, perhaps particularly the liquid applied coatings. Other coatings, you actually land up heating the system. So a hot pipe is not necessarily a problem. So temperature is one thing. You may well see some situations where the pipe laying crew carries a mobile tent with them, like a pergola. And this gets erected over the joint in order to provide some protection during the field joint coating process. I think the bigger challenge actually is wind, because wind carries dust. And it doesn't matter what you're putting on the surface, whether it's one of the tapes, one of the hot applied systems, one of the liquid applied systems. If you get dust on the surface during the application, you're heading for trouble, because dust is a wonderful bond breaker.
Eliminator, yes.
Yes, absolutely.
If I can just introduce an advert right here, everything that we spoke about in our coating series last February is available still on YouTube, and you can go and watch those. But we discussed the environmental aspects in quite some detail, because, as you rightly say, that dust is a major challenge. And doing anything on site, even if you're just writing something on a piece of paper, you get back and you realize the piece of paper is now brown stained, your hands are dirty, and you've probably not thought that you touched anything. So I can imagine trying to keep that steel in some semblance of order is quite challenging. Neil, in terms of skill, the personnel installing the pipe crews will be a pipeline installation contractor usually, and they are very skilled at maneuvering pipes and so on. Your welding guys obviously come in to weld the pipes, but actually applying the field joint coatings, is that something that the construction crew can do?
I'm a firm believer that every construction crew has to be trained in the particular system that they are applying, whether it be a tape wrap where you have to maintain constant tension on the tape, or a hot applied system where you're waving propane torches around, trying to heat the surface and heat the tape and not heat each other and get it on right and so on, or whether you are using a liquid coating where you have to grit blast the surface, or right, it's sweep blasting, but it's still a blasting operation. And then having done that, you've got to clean the adjacent factory coating to the correct degree. And then the avoidance of a step change from the factory coating to the field joint coating has got to be chamfered. The use of squish packs. If you're using a twin pack liquid coating, you have to mix it properly. You have to apply it within a certain time. You've got to get the film thickness right. So every type of field joint has its own challenges. There is no one silver bullet that will coat every single different pipeline situation with the same ease and lack of hassle, let's put it that way. And the field joint that you choose is very dependent on the factory coating that you have, firstly, and secondly, the size of the pipe, the number of joints that you have to actually do. If you're doing one or two joints in a repair situation or laying a fill-in piece or something like that, very different story to laying kilometer after kilometer of pipe through the open field, where you're going to land up with a almost like a production train. So the preparation of the trench. Now, if you're going to have to crawl in underneath the pipe in order to blast and spray, you need space. That means that whoever prepares the trench has to prepare foxholes at the right points for the field joints. Those are needed for the welders anyway, if you're welding in the trench. But some pipes are fabricated or strung, as the word is used often, outside the trench and are then snaked into the trench. So the field joint coating is done next to the trench, which is great because you've got easy access and you can just drop it in the trench. But if you're fabricating in the trench, you then have to have these accessible areas every 20 meters, which is a more complex excavation procedure.
Neil, just going back before we head into choosing the actual coating, we were talking about the skill level of personnel. We're based in a country where skills are notoriously quite poor. Is there training for personnel? Is there field joint school that one can attend?
Oh, I wish. Unfortunately, not that I know. It's like that QBE from the University of Hard Knocks, and the training often happens in the field. What we frequently see happening is that prior to a project being commenced, they do quality pre-production trials or pre-qualification trials in the factory, where they set up a miniature field joint, miniature in terms of the length of pipe that's used. Field joint itself is a regular size. And then the crews that are going to be working in the field have to come in and apply the coating, which they then do in a controlled environment, which makes it a lot easier. But you can check whether the procedures are carried out correctly. It is up to the installation contractor to then ensure that his personnel are trained. And equally, as far as I'm concerned anyway, it is up to the material supplier to offer the necessary training in the application of their material. Because if it goes wrong, it's the supplier who's going to get nailed as having a product that is not up to scratch.
True. And Neil, who would choose the field joint coating? Is that specified in every project at the outset with the line coating? Or do the contractors have some say in the matter? Or is it a prerogative of the project engineer? Who would be making that decision?
Well, sometimes it's specified in the actual project documentation that a particular field joint system should be used. But a lot of the choice is dependent on the skill level of a contractor. So if you have a big long distance overland pipeline, you're going to have a contractor with a probably a lot more experience, a lot more resource than a contractor who is doing a small municipal project, for example. And for the guy doing the small project, for him to then lay out very, very expensive plural component hot spray equipment is just not viable. So there's always a case of ensuring that your conditions that the pipe is going to be laid in are matched to the system that is selected. I suppose it's the other way around. You select the system that is matched to the conditions. So there's always more ways of skinning the cat than choking it with cream. So you may find that if you have a polyurethane coated pipe, for argument's sake, you could either coat it with polyurethane in the field. Again, there are different methods of coating it in the field, or you could tape wrap it. There is a variety of tapes available. What's the availability? What's the cost? So those things all come into it. The bottom line is that the field joints must match the mainline coating or the factory applied coating in terms of their mechanical properties, electrical properties, and the electrolytic properties, the corrosion properties, in other words. Because otherwise, you'll end up with a situation where you have this wonderful pipeline coating that's resistant to mechanical damage. You can throw it in the trench. You can throw the run-of trench soil back on the pipe without thinking about it. You can use run-of trench backfill. Usually it's material that is very fine-grained, or it has been sieved and thrown back in the trench. But it may include material up to 20, 30 millimeters size, small stones and so on, gravel. If you use a field joint coating that is not up to the same level of mechanical strength, you then have to have a special backfilling for every pipe joint so that you don't land up damaging the pipe joints. The picture behind you is a wonderful example of a field joint. In that case, the field joint wasn't coated at all. And you can all see the net result. It corroded through and the water came out the other hole. And so the field joints have to be considered in the overall construction of the pipeline.
To me, that's always a worry. I feel as though field joints are so often the afterthought, like the Cinderella of the process. They just get forgotten. And then by the time they're considered, they're under time pressure, there's budgetary constraints. And very often my gut feel is that there's a sacrificing of the whole pipeline integrity because the field joint coating was an afterthought. What's your perspective on that?
It can happen for sure. And some of the better written project specifications will actually state that the preferred coating system is XYZ with field joints done either by A, B, or C, if there are a number of options. And I've often had situations where I've been approached by project engineers where a particular material has been specified, and then the contractor has come along with an alternative to say, well, can I use this? Or why do you want to use it? Oh, because it is less expensive, or it's more available, or it requires less preparation on site, or because I didn't think about it, or whatever. And sometimes you have to be hard and say, no, that's what's specified. That's what you quoted for. That's what you've got to do.
And I think one of the other challenges, aside from financial and budgetary, that I alluded to is the production rate, is that very often the field joints, especially if the external field joints haven't been repaired as quickly as the mainline is being strung, that there's now this time pressure. And realistically, one can only wrap at a certain rate, for example, or apply the liquid coating at a certain rate, and yet there's pressure, or it needs time to cure, and there's pressure to finish quickly and get it backfilled. That also puts the field joint at risk.
Very much so. And again, depends on almost call it the quality of the project specification. A lot of specifications from the likes of the big utilities will say that you may not have more than, say, 500 meters of pipe exposed before it is backfilled. And the contractor then has to plan to ensure that he can, in fact, coat those joints at the same rate that the pipe is being put in the ground. And one of the biggest disasters, well, eventually it turned out not to be a disaster, it was a disaster from a project point of view, was a situation where the contractor laid the entire pipeline without doing the internal field joints. And they had to go back in and do the field joints after the pipeline had been laid. It took them years to get it right. If they had planned it properly and done look, inside the pipe, it's dark. You can do your field joints at night internally. Doesn't matter. Even in broad daylight, you've got to have light inside the pipe. So, you can lay the pipe during the day and do the field joints at night. The internals, we'll talk about the internals later in the program.
Well, I think if we step back and we say the perfect field joint coating must be something that is a perfect match with the mainline coating, I'm sure that's the ideal.
Perfect match does not necessarily mean the same material. You can take the fairly high profile stance that if you've got a polyurethane pipe, you must have a polyurethane field joint. Or if you've got a bitumen pipe, you must have a bitumen field joint. Yes, that is perhaps the preferred system, but you can create an equally fit for purpose that meets specification and life expectancy and everything else by using alternative materials, provided they have the matching properties, as I mentioned, mechanical properties, electrical properties, and electrochemical properties.
Well, Neil, I think you've given us a lot to think about. Thank you. And I think we're going to be headed into a really interesting series of discussions over the next couple of weeks. And you've really helped start us. I suppose we could look at it and say that the field joint coatings could in fact be the Achilles heel of the entire pipeline. And we really don't want to overlook them. If we do them right, we'll end up with a really worthwhile project at the end of it.